our first problem we have, this problem says a question mark, but it's I scrolled down to see the solutions here, and it's asking us very much what is sine 3 pi over 4, and that's the question we're asking. That's the first question of the day, or what is the exact value of sine 3 pi over 4? So this is some type of question mark, so we don't know this. So what we're doing here is, this is a question that you would probably find in grade 11 context in the trigonometry kind of unit, when we're asking about how to first look at 3 pi over 4 and recognize that it's in radians, and then also how do we find equivalent trigonometric ratios in order to solve this problem here. So what we're going to do first for this problem is, how do we find sine 3 pi over 4? Well, we have to write down our axis first, right? So let's draw our axis here. So we have 0 and 2 pi on this line here. We have pi over 2 on this line. We have pi here, and this guy has to be 3 pi over 2. If you're thinking in terms of degrees here, this is 0 and 360. This y here would be 90. This guy here would be 180, and this guy here would be 270 degrees. But however, we're going to look at radians. So I would like to draw this in radians because our problem is also in radians as well. So as you can see, 3 pi over 4 here, if we want to determine where this is on the axis, what we can do is we can actually use 3 pi over 4, and you can see it's kind of close to 4 pi over 4 here. Or let me do a 4 pi over 4, which is almost, this is equal to pi. So 3 pi over 4 is just simply a little less than pi. So I can say that 3 pi over 4 is less than pi, which means my angle is going to exist over here. Let me see if I can draw a straight line here. There we go. So this angle theta here is going to be theta equals 3 pi over 4. And the equivalent angle of this is going to be, let me write down, use another color here. This angle here is going to be pi over 4. So I'm going to say here angle, this is angle 1 here is going to be pi over 4. So again, now we found our equivalent angles, right? Because again, this entire angle here is 3 pi over 4, which means this angle must be pi over 4, right? Because 3 pi over 4 plus pi over 4 equals pi. So that's how we know that these two angles are equivalent. And what we can do now is we can actually use our equivalent trigonometric ratios. So we know that first we have to figure out our cast rule, right? And our cast rule is simply just a mnemonic for us to figure out in which quadrants specific trigonometric ratios are either positive or negative. So this here is a C, this here is A, this here is S, and this here is a T. So C for cosine, A for all trigonometric ratios, sine for sine, and T for tangent here. Or sorry, S for sine and T for tangent here. So what we can do now is we can figure out, okay, where does our angle lie in? Well, we know that it's going to lie in quadrant 2, right, where the sine quadrant is. So you know that sine here is also going to be a positive value. If this angle was in the tangent or the cosine area, or in the quadrant, sorry, it would be a negative sine ratio. So we know that now, we know that sine here is positive. So what we can do now is we can actually take our equivalent trig ratio and actually apply our special triangles for us to figure out what this is here. So we're going to take pi over 4 as our equivalent trig ratio. Now, before we solve this problem here, what we can do is we know that we need one more piece of information to solve this problem, and this here is our special triangles. So special triangles here, for specifically this case, we care about pi over 4 or 45 degrees. So this here is going to be a pi over 4. So both of these guys here are pi over 4, and we know that in a 45, 45, and a 90 degree angle here, we have 1, 1, and root 2. So we have these, so this here is our special triangle, which means now we can solve for what this guy is, right? So sine here So sine 3 pi over 4 is going to be equivalent to the sine pi over 4 in the second quadrant. So we can say this is going to be equivalent to sine pi over 4. And this is going to be, again, positive because I said that this lies in the positive, in the second quadrant, which makes sine positive. So we can say sine pi over 4 equals, so now all we have to do is simply just plug in our trig ratio, right? So we know that it's going to equal opposite over the hypotenuse, which in this case here, we have opposite here, which is going to be 1, and the hypotenuse here, which is root 2. So we have, this is going to equal 1 over root 2. So at this point, what you can do, you can leave this answer as 1 over root 2, or you can rationalize it by multiplying root 2 to both sides, or to the top and the denominator. So you get root 2 over root 2. So this is sine pi over 4, and this is also sine pi over 4. Which means, if I know that sine pi over 4 is 1 over root 2, then therefore, I can say that sine 3 pi over 4 is also equal to 1 over root 2, or root 2 over 2. And this here is going to be the solution for our first question. So let's look at the problem. Let's look at the problem now, and let's look at how they got to this answer here. So what they did here was they explained what the trigonometric ratios first, and then they figured out in terms of our opposite adjacent hypotenuse where the ratios are. And they have in degrees here, but we're actually going to do it in radians. So this here, yeah, they converted to, what they did was they actually converted to degrees first. I prefer working in radians because most grade 11 students will have to work in radians eventually. So this here is good if you're working in degrees, but I prefer working in radians in this case. But so I didn't have to do this step if I knew where the quadrants were. So if you don't know how to work in radians, or if you're a little bit uncomfortable with doing that, what we can do is we could actually convert radians into degrees by simply multiplying by 180 degrees over pi. But you're going to realize that 3 pi over 4 actually exists in the second quadrant, so at 135 degrees. So in this quadrant, so which is good. And what we can do now is we can look at what they did here was they actually plugged in their equivalent trig ratio, right? So they plugged in this first equation, trig ratio here, which is sine 180 minus theta, or angle A, equals sine theta. So we know that in this quadrant here, sine is also positive. So they know that sine 135 is equivalent to sine 45. And sine 45 here is simply just pi over 4. So as you can see, they wrote that sine 45 is 1 over root 2, which is our answer here. So therefore, sine 3 pi over 4 is also 1 over root 2. So the solution here is correct. I personally don't like, I like their solution here, but I prefer that if they worked in radians, it might have been better, just because it's a little bit confusing when we're talking about, when we're converting from sine 3 pi over 4 to 135, and then sine pi over 4 back to 45 degrees. So this solution here is correct, but I wish they kind of stayed in their, in radians instead of degrees here. So that's all I have here. So solution, good analysis. So solution here is correct.